Hello everyone. Today we will start correlation and regression. So first is scatter diagram or dot diagram. The diagrammatic representation of bivariate data is scatter diagram. So what is bivariate data? Bivariate data, so far we have considered the data arising out of investigation of one character only, and these are known as univariate data. But situation may come when we are to study the data which arises out of investigation of two characters, and then this data will be called bivariate data. Let x and y be two random variables defined on an event space S of an experiment. Then the pair x and y is called bivariate on the same event space. As for an example, we may consider jointly age and height of a person, or we can say marks of both in mathematics and physics of a student, or we can say age and blood pressure of persons, etc. This collection of simultaneous measurement of two variables is known as bivariate data. In bivariate data, generally one variable is denoted by x, other by y. So now again we come back to scatter diagram or dot diagram. So let x1, y1, x2, y2, xn, yn be in number of bivariate data. For each xi, yi, we get a point pi on the xy plane whose coordinate is x and y as shown in the figure. So here in the figure we have seen points are position, they are scattered in position, and we can represent it by dot, so which is known as dot diagram or scatter diagram. Next is different type of scatter diagram. So in figure 1, the association between the two variable x and y is positive. That is, if x increases, y has a tendency to increase also. In figure 2, the association between the two variables x and y is negative. That is, if x increases, y has a tendency to decrease. Next is figure 3. The association between the two variables x and y is 0. That is, there is no association between two variables x and y. Number 4. The association between the two variables x and y is perfectly positively associated. That is, if x increases, y also increases and never decreases at any stage. Next, number 5, that is figure 5. The association between the two variables x and y is perfectly negatively associated. That is, x increases, y decreases and never increases at any stage. Next is correlation and its different types. If y has a tendency to increase as x increases, we say x and y are positively correlated. That is if the scatter diagram like figure 1 of the previous article, then we can say x and y are positively correlated. Same way, if y has a tendency to decreases as x increases, we say x and y are negatively correlated. That is, if the scatter diagram like figure 2 of the previous article, then we say x and y are negatively correlated. And if the value of y are not affected by the changes in the values of x, then we say that x and y are uncorrelated or zero correlated. So these are the correlation and its different types. Next is covariance. Covariance is let x and y be a bivariate data assuming the n number of values, and here x1 x2 x3 xn and y1 y2 y3 yn. Then the covariance of x and y is, we can denote it by cov of xy, meaning is covariance of xi, and here we will denote by cov of xy. So 1 by n summation of I equal to 1 to n xi minus x bar yi minus y bar, where x bar and y bar are arithmetic mean of the values assumed by x and y respectively. So just here we will put the formula of this. So after simplifying, two terms will be cancelled out and two terms will be there. So this is the formula of covariance, or we can say curve of xy. Next is one regarding problem. So number one question is, for the following bivariate data, find the covariance. So here x colon minus 2 minus 1 0 1 2 corresponding the values of y 4 1 0 1 4. So here we will use the above formula. This formula we will use 1 by n summation of I equal to 1 to n x I y I minus of 1 by n summation of I equal to 1 to n x I 1 by n summation of I equal to 1 to n yi. So here accordingly this we have to find out sum of xi, sum of yi. Another thing is important that we require, that is sum of xi yi. So curve of xy, just use the formula and we will put the formula and we will put the corresponding values of the formula. So your answer is 0. So here covariance of xy is 0. Next is correlation coefficient. So what is correlation coefficient? Let x and y be a bivariate data assumed by a bivariate x and y. Then the correlation coefficient of x and y is denoted by rho xy or rxy, whatever we can write. So curve of xy divided by sigma x sigma y. Curve of xy means covariance of x and y, and sigma x sigma y means corresponding standard deviation of the values of x and y respectively. So next is another question we have, that is finding correlation coefficient. So what is the question? For the following bivariate data, find correlation coefficient. X equal to minus 6, minus 4, minus 3, minus 1, 1, 2, 4, 7, and y is minus 4, minus 3, minus 1, minus 1, 0, 2, 3, 4. So corresponding table is there. xy, x square, y square. So corresponding values of x is given, corresponding values of y is given. And now here xy equal to minus 6 minus 4 24, minus 3 minus 4, that is 12. So in this way we can calculate. So before going to find out, first we have to write the formula, because according to the formula we will decide which columns we need. So first we have to find out curve of xy. So curve of xy, first write down the formula, then keep some space for calculation. Again you will write the formula of sigma x square for the standard deviation. Again keep some space for calculation. You will find sigma square y, again keep some space for calculation. So after this you will find we have to find out for the table summation of xy, we need sum of xy, we need sum of yi, we need sum of x square, we need sum of y square. So these few columns we need. Okay, accordingly you will arrange the table. Actually we need the sum value. So summation of x, summation of y, summation of xy, summation of x square, summation of y square. So accordingly we will put the value. So you will find out curve of xy is 21 by 2, sigma x square is 32 by 2, and sigma y square is 7. Okay, so ultimately our formula is rho of xy equal to curve of xy divided by sigma x sigma y. So this is 21 by 2 and divided by root over of 32 3 by 2 and into root over of 7. Just see here, we found here sigma x whole square and sigma y square. So according to our formula we need sigma x sigma y. So that's why root over of 33 by 2 root over of 7, and this is 0.977. So this way we can find out correlation coefficient. Next is a few important theorems we have. So first is, if u and v two standardized variates given by u equal to x minus x bar by sx and v equal to y minus y bar by sy, then u bar equal to v bar equal to 0. Number 2 is, correlation coefficient is independent of the change of origin and change of scale. Okay, or we can write, if uy equal to xi minus a by b and v equal to yi minus c by d, where I equal to 1 to n, where a, b, c, d are constant, then rho xy equal to rho uv or rho xy equal to minus rho uv. According to b and d are the same sign or the opposite signs respectively. And number 3 is very important. For any bivariate data given by xy, -1 lesser equal to rho of xy lesser equal to 1. So where rho xy is correlation coefficient of x and y. And number 4 is, if the two variables x and y are independent, then they are uncorrelated. So these are the important theorems. Next is the proof of the relation -1 lesser equal to rho xy lesser equal to 1. So according to the important theorem, we know that u equal to x minus x bar by sx and v equal to y minus y bar by sy. So now we are taking summation both sides and squaring both sides. So what do you get? Summation of I equal to 1 to n ui square equal to summation of I equal to 1 to n xi minus x bar divided by sx whole square. So taking common outside 1 by sx square. So what is remaining? This one is remaining. This one means again sx, nsx. As we know that sx square is, this is the formula. So in this place we can write n into x sx square. So this cancel out. So we have n. Similarly, for the value of summation I equal to 1 to n v I square, also n. So again, we need summation of I equal to 1 to n ui vi. So just we will use the formula accordingly ux, u and v, and just you can write here. So we know that this is the formula of correlation coefficient. So this will be n into rho of xy. Now, since this is the condition, this is true always, ui plus vi square whole square always greater equal to 0. So now we are taking summation both side, and after taking this, so here a plus b whole square, so here a square plus b square plus minus 2 of ui plus ui into vi. So just use the formula, just use the value already we got. So n plus minus 2n rho of xy. So taking common 2n, and it will be 1 plus minus rho of xy greater equal to 0. So here two cases arises, 1 plus 1 minus. So when 1 plus rho of xy greater equal to 0, then we can write -1 lesser equal to rho of xy. When 1 minus rho of xy greater equal to 0, we can say rho of xy lesser equal to 1. So after combining this one and this one, we reach -1 lesser equal to rho of xy lesser equal to 1. Okay. Next is interpretation of correlation coefficient. So when rho of xy equal to 1, so we can say that correlation is perfectly positive, and this indicates that there is equal proportional change in the same direction. Next is rho of xy minus 1. We say that correlation is perfectly negative, and this indicates that there is equal proportional change in both the variables, but these changes are in opposite direction. This one. And when rho of xy equal to 0, we say both the variables are uncorrelated. It is to be noted that when two variables x and y are independent, then curve of xy equal to 0. But the converse may not be always true. Next is regression line. Regression line. So before going to tell you two types of regression line, we should know that what is the meaning of regression line. So by the word regression, we want to denote the estimation or the prediction of the approximate value of one variable for specified value of the other variable. On the other words, it stands to measure the average relationship between different variables. So regression line, there are two types of regression lines as mentioned here. Number one, when it is required to estimate the values of the dependent variable y for different values of the independent variable x, then the regression line of the form y equal to a plus bx, and it is called regression line of y on x, and this is used to estimate the value of y when that of x is known. Okay. On the other hand, when x is taken as dependent variate and y as independent variate, then the regression line of the form x equal to c plus d y bar, and it is called the regression line of x on y, and this is used to estimate the value of y when that of y is known. So now finding the regression line by method of least square. So here regression line of y on x is y minus y bar b of yx, x minus x bar, or we can say y minus y bar rho of xy sigma y by sigma x, x minus x bar. So here byx means rho xy into sigma y sigma x. This is the regression coefficient y on x. On the other hand, x minus x bar equal to bxy, y minus y bar. So x minus x bar equal to rho of xy into sigma x sigma y, y minus y bar. So this one is b of xy, which is also regression coefficient of x on y. Next is properties of regression line and coefficient. So for a bivariate data given by xy, the correlation coefficient and the regression coefficient have same sign. Number 2, byx into bxy equal to rho xy whole square. Number 3, the gradient of regression line of y on x is byx, and the gradient of regression line of x on y is 1 by bxy. And the regression coefficient byx equal to curve of xy divided by sigma x square, and bxy equal to curve of xy divided by sigma y square. Now the rank correlation, so the product moment correlation coefficient rho xy between two variable x and y can only be calculated when the values of these two variables are known. But situations may arise in practice when such precise measurement are not possible. Say, we are going to calculate the relation between intelligence and the beauty of a group of individuals. It is our common experience that we cannot say the beautiful person must be intelligent also. To compare in such cases, we first arrange the characteristic, say A and B of the individuals in order to merit or proficiency in the procession of the qualities using number 1, 2, 3 dot dot dot. So this method of numbering according to the merit is called ranking, and the number allotted to a particular character is called rank. So the correlation coefficient between two series of rank is called rank correlation coefficient, and the formula is r equal to 1 minus 6 summation d square divided by nq minus n. So where d is the difference of the rank of an individuals in the two character and n is the number of individuals. And this formula of rank correlation R is also known as Spearman formula, Spearman, Spearman's formula, and it can be proved the rank correlation coefficient lies between -1 to +1. We can write -1 lesser equal to R lesser equal to 1. So here is one question is there. For the two variable x and y, the equation of two regression lines are x plus 4y plus 3 equal to 0 and 4x plus 4y 9y plus 5 equal to 0. Identify which one is y on x. So we will not, we don't know which one x on y and which one y on x regression line. So we will take the trial and error. First we will assume first one is y on x, second one is x on y. Then we will use one condition. If condition satisfied, we can say yes, our assumption is true. If condition not satisfied, we can say our assumption not true. Opposite assumption is true. So that's why we have written let if possible. So this one y1 x and this one x1 y. So we will find the gradient. Gradient is -1 by 4, and here this one, and gradient of second one is -4 by 9. That means bxy is -9 by 4. So according to the condition is rho xy square equal to byx into bxy, that is minus 1 by 4 into minus 9 by 4, that is 9 by 16. So we know that rho xy square must be less than 1. Okay, so and here also we got 9 by 16, that is less than 1. That means our hypothesis is correct. So whatever we are taking the assumption, that is our correct assumption. So we can say yes, this is the first equation is y on x and second equation is x on y. Next is another question we have. In a class of 10 students, obtain the following marks in mathematics and physics out of 100 each. Find the rank correlation coefficient of the marks obtained in the two subjects. So here maths is there, physics is there. So we will write one column in maths column and we will write in another column, that is physics column. So now rank in X. How do you find the rank in X? So first we have to select which one got the highest mark. So 98 highest mark. So that's why it is considered as 1. Next highest marks is 92. So this is considered as 2. Next highest marks 82 considered as 3. So in this way we will find the remaining also. Now ranking Y. So same way we will check which student got the highest marks in physics. So that is 91. Next is 86. So in this way we will arrange it. Now the D means difference, modulus of x minus y. So 10 minus 3 is 7. 7 minus 8 is minus 1. Since it is modulus sign is there, so 1. So in this way we will find the remaining values also. Next is d square. D square is just squaring the value, previous value. So here 41, 1, 0, 9, 0, 4, 0, 1, 25, 1. So we will add all the value, that is 90 value. So the rank correlation 1 minus 6 summation d square divided by nq minus n. So a 6 into summation d square means 90, n means 10, so 10q minus 10. So here value is 540 divided by 990, that is 0.0455. Okay, so in this way we can easily calculate the value of the rank correlation coefficient. So here all of you, today we will finish our this portion here, and next again we will make the video for next topic. So till then, bye all of you.